Hey everyone, so welcome to my lecture one of the Introduction to Artificial Intelligence series. Today we are going to talk about agents and different sets of environments. And first, I would like to discuss a little bit about why does it even matter? You know, why do I need to study about different types of environments and why do I need to study about agents? It's so obvious and everything. But for sure it is obvious, but we have to still define the different types of agents and environments. And this is very crucial and very important because if we do not know about the different types of agents and different types of environments we have, then the knowledge or the algorithms that we will study later on, they are just useless because you are just studying without any purpose, right? So when we will define different types of agents and environments, then you will have this purpose now that okay, this is the type of environment I'm studying these algorithms for. And in real world, we actually have lots of different types of problems or environments, you can say. One environment can be, let's say, you want to build an AI for a game, right? And that game can be a simple thing like a Pac-Man, right? Or it can be a car racing game where it's super simple, and when you take an action in that game, an action can be something like you pressing the right key on your keyboard. Now you are 100% sure that your car or that Pac-Man main character dude will actually go towards right. You are 100% sure about that, right? And you're 100% sure that if you will take an action to go left, then you will actually go there, right? And there is no other thing. But then there is another type of environment, right, which is real world. And the best example I can give you to explain this environment to you is uh, a self-driving car stuck on a traffic signal, right? And the way you can actually understand is, let's say your artificial intelligence now needs to drive this car, right? And um, what can happen is, let's say it wanted to take an action to go right towards the right side of the road. And now the problem is, it's not 100% possible or probable that it will actually go right, because things can mess up. It's real world, and things can mess up in a way that let's say your engine got broken here, right? Your engine just died here. So even though you took an action to go right, you are still at the place that you were on, right? That you were in initially, you are still there. Or what you can say is, let's say you wanted to go straight, but your tires drifted, or there was something wrong with your car's tires and you actually drifted towards the right. Or also a really logical example can be a pedestrian just came in front of you out of nowhere, and even though you took the action to go straight, now you are still stuck with the initial position of yours, because you cannot actually kill that pedestrian, right? So here things are a bit indeterministic. Even if you take an action, and that action can be to go straight, you it's not 100% let's say 100% surety. There is no 100% surety that you will actually end up going straight, right? So, and if you really think about it, if we do not code or make our AI in a way that it might actually stop if it sees a pedestrian, then it will just like hit the pedestrian, right? It will kill the guy, and that is something that we do not want, right? So we have to take in order different probabilities. Then now you can say, okay, Usher, but this thing that you are saying is very, very rare. Yeah, sure, it is rare. Maybe it has 1% chance of happening, but still, that makes your environment indeterministic, right? You cannot be like 100% sure that it will actually do what you intended it to do, right? So this is a different type of environment now, and this was a deterministic environment because you knew that if I do this, if I take an action to go straight, I will go straight no matter what, right? So there are different types of environments in the world. We will go much deeper in this lecture about different types of environments, but this was a very basic example. And the reason I wanted to explain this was, now if you want to build AI for this Pac-Man game, right, you would actually need a different agent from the one that is driving this self driving car, right? So these two agents must be different, and these two agents must have different properties, different algorithms, different programs, right? So this is basically why we need to study about different environments and agents. Okay, so now I have been using this word agent and agent a lot, right? So what exactly is an agent? The way I like to think about this is, an agent is mainly the main character of your story. Let's say if I want to build an AI for my Pac-Man game, then my main character would be that yellow Pac-Man dude, right? So that is an agent, right? If I want to build a self-driving car, so the main character in my story is the self-driving car. So that can be an agent. And let's say you want to build a walking robot, right? Then that robot is the main character of your story. But that's not always true, because let's say uh, you have this Pac-Man game, right? Now in those Pac-Man game, you also have the villains, and these villains actually want to kill you, right? They want to eat you, but you want to escape them. So if you want, you can also make these AI, right? You can also do like make them artificial intelligent agents as well. So in that case, now even though these people, or what you can say, these monsters are not actually a main character, but they are still an agent, right? So whoever you are trying to make intelligent, that is an agent, right? That's the simplest thing you can take or understand this. What is an agent? Agent is either the main character, or is it's an entity that you are trying to make intelligent. Okay, now as we mentioned, what is basically an intelligent agent? Now I can give you a very lame definition and end it here, which is, it an intelligent agent is someone or something that just shows intelligent behavior. Now it's literally like I just did a 360 or 180 flip back to my question. And what exactly is intelligent behavior? Now I can give you another lame statement, which is that intelligent behavior just means intelligence. But the main problem here is, what exactly is intelligence? Now a lot of you guys would be like, yeah, yeah, I know what is intelligent, why are you wasting time here and stuff. But if you if I ask you to define intelligence in a definition, right? Like let's say there's an alien that has just came into this world, and you have to define intelligence to them. How will you define? What are the sets of words that you will use? Now when we go in such depth of this word intelligence, that's where we are like, oh, okay, maybe I'm not so sure what is intelligence. So, intelligence is a very simple thing. Intelligence just means that uh, having an ability to acquire and apply knowledge and skills. Now, this is extremely important, because in this whole course of this whole AI thing, and even in the whole field of AI, you are just doing these two things. You're acquiring knowledge, and then you're applying knowledge. So, acquiring and applying knowledge. If you can do these two things, then you possess intelligent behavior, or you are an intelligent agent. So another keyword that you need to know is, what is rationality? Maybe you might have heard this somewhere, that somebody is saying that you are being irrational or your argument is irrational. So basically, what is rationality? What is irrationality? And why does it matter in this case? It has a huge connection, and I'll come to that point. So rationality just means that you have this quality of reasoning with logic, or you have this quality to reason about things, to be logical. Like if you are trying to argue with someone, you are actually arguing logically, and you are reasoning about things. So in basic terms, rationality means the quality of being based in accordance with reason or logic. That's it. Now, there's a loophole, or you can say there's a confusing part here, and I'll explain to you with a very quick example, which is, now let's say I build this program where I feed it lots of information, right? I just feed it lots of information. I feed it a whole information of the world, right? I just feed it all the information, and then I ask something from it. Is that person, or is this program rational? And let's go a little back, and let's try to ask, if I ask something from it, from this program, and this program has knowledge about everything in the world, will it answer me? Yes, it will answer. But will it be rational? No. And this is the point where I will explain what rationality means. Rationality is not the same as knowing everything. This is a confusing point. By the way, knowing everything is also called as omniscience. So, yeah. And the problem with knowing everything is, for sure you can answer stuff, but then you are not actually being intelligent if you think about it, or you are not actually being rational about it. So what it means is, if I hard code in my program that 1 plus 1 is 2 and 2 plus 1 is 3. Now if I will ask it, is what is 1 plus 1, it will answer me, yeah, sure, what is 1 plus 1. If I ask it what is 2 plus 1, it will answer me, because it is hard coded in its knowledge. This is in knowledge, right? But the problem will begin when I will ask it what is 3 plus 1. Now it will be like, okay, I don't know anything about this 3, right? And this is the problem with being omniscience, or with just knowing everything instead of being rational. So, if an agent is actually rational, what it will do is, or what it will be able to do is, it will be able to acquire new information. And it doesn't need to be that, we will feed information into it. If if we if we make it rational enough to understand what is addition, and what are 1 2 3 and all these numbers, Then if I will ask it anything, like if I ask it 3 plus 1, then it will be like, okay, 3 is a number, 1 is a number, plus means additions. That means I have to just add 3 into 1, and that basically means 4. Now if I will give it any big number, it will give me some answer about it, instead of just looking up in its knowledge and giving me an answer. It will be able to reason about this, it will be able to think logically about this, and then form an answer and then give it to me, right? It didn't knew what this is, it didn't knew what this is, it didn't knew what is the answer of this, but it was able to interpret it, right? So that is rationality, and this is what is our aim. We want to make our agents rational, we do not want to make them omniscience, you know and by the way, sorry, omniscientist. And by the way, one more thing, it's not actually possible to make an agent omniscientist if you also think about it. Or even if it is possible, then it's not really efficient. Like, just think about it, what is better, if I store like billions and billions and billions of terabyte of data, which is just like which is just like knowledge, which is like terabytes of terabytes of terabytes of billions of terabytes of just knowledge, and then it will just look up in that such a large data, such a large knowledge, and then it will bring an answer to me. Will that be better, or will this be better, that it can just actually perform some logic, perform some calculations, and then give me? Obviously the second option is better, because that's much quicker, that's much more efficient, and that's actually more closer to the definition of being intelligent, of being artificially intelligent, right? So this is what rationality means, and we want our agents to be rational. Okay, so human beings don't know everything, but they can learn new information, hence, they are also rational, right? So, we just want our agents to acquire new information from the environments, just like the humans, right? So, an rational agent means it should select its actions to maximize its criteria for success, given the agent's knowledge and perception. Now, what is perception? Perception just means being aware of something through your senses. That's it. If you are aware of something through your senses, then you have a perception of something, right? If let's say I touch a hot cup of tea, then I can perceive that that's a hot cup of tea, because I have touched it, because I have sensed it. So, that basically just means perception. Okay, so one last point, agents should be, or are said to be, autonomous if their behavior is determined by their own perception, experience, and decision making process. And this is what we want. We want our agents to be autonomous, unless you are anti AI. You want it to be autonomous, right? It should, just determine things by its own experience, knowledge, perception, and decision making process. So this is all about agents and a little bit about environments. Now let's talk about what are the types of agents. The first type we will see is actually reflex agents, and these are very simple to understand, extremely simple. If you have ever even done let's say basic coding, then you have even built reflex agents. Now, let's talk about the characteristics of a reflex agent. Reflex agents are simple. They are rule-based agents that makes decisions based upon their current perception or input without considering the history of their past perceptions. Okay, now a very simple example of this can be, let's say, a thermostat in a heating system, right? A thermostat in a heating system that turns on the heater when the current temperature falls below, let's say, 20 degree. So what happens is you have this thermostat and it is sensing, okay, what is the current temperature, what is the current temperature, and in its code it just know one, it just have one if condition, that if temperature is less than 20 degree, then turn on heater. That's it. So when I said that you have built reflex agents, if you have any experience with programming, basic experience, because you have built programs using if statements, right? So you have built reflex agents. So what it is basically doing is, it's just, it has this rule and it is following that, right? So this agent's action are determined by a set of predefined rules or condition action pairs. This is a condition action pair, right? The condition is this if condition and the action is this thing. So if the agent is just, have a condition action pair or has predefined rules, then it's a reflex agent. That's it. And these rules map directly from the perception to an action without considering the overall context or future consequences. Okay, so one example I can give you for this is, let's say it had its sensors here, right? And what I did was, I just brought something extremely cold, or like a set of ice cube, and I placed on it here. Now it doesn't have the overall context of the whole room. It just, it is just acting upon what it perceives, what it senses. And I have, let's say, put lots of ice cubes on it, and even though the temperature of the room is not actually less than 20 degree, but its sensor has sensed that it is less than 20 degree, then it will just turn on the heater, right? So it didn't consider the overall context. And one more thing is, let's say you were having some sort of food. Now this would be a weird example, but yeah, let's say if you have some sort of food and you don't want it to get cold, you want to eat hot food, right? Or you have a cup of tea that you want to drink and you don't want it to get cold, even if the temperature of the room, um, uh, okay, sorry, let's say you have this hot food and you don't want it to get cold, and you don't want this hot tea to get cold. um okay, I'm messing up a bit. Let's say you have this cold drink or soda, you can say, and you don't want it to get hot, you want to drink it cold, but the temperature of the room fall below 20 degree. This thermostat will turn on the heater, and it will actually heat up this soda of yours, and then it will become hot, right? Now this is a weird example, but the main point of it is, it does not it didn't consider the consequences, the future consequences. Or one way we can also think about it is, which I think is a better example, is, let's say you have put this thermostat in a place where, if the room is hot for a long time, then it will let's say there will be lots of problems, right? Maybe this thermostat is in a freezer room, You don't want it to always stay hot, or stay hot for a long time. So it won't care, because it just knows this thing. That's it. It just knows this thing. So it doesn't care about future consequences or overall context. It just says, is this condition being fulfilled? If it is, do this. That's it. So this is a reflex agent. Okay, now we have this another subtype of this, which is called reflex agent with a state. This is called reflex agent with a state. Okay, so reflex agent with a state maintains an internal representation of the current state of the world. This current state allows the agent to consider not only the current perception but also information about the history of past perception and actions. So now what you can think is, an example for this would be, to better understand what I just said, is an elevator control system, like just like a elevator, right, that you take. Now an elevator considers both the current floor button press and the direction in which it is going, right? Let's say you have this elevator, you are in on 6th floor, right? And this elevator showed you that it is going up, and maybe it is going up because someone at the 8th floor has called it. Someone at the 8th floor has called it, so it is going up. But what you did was, you came inside and you pressed the downwards button. Now if we had a reflex agent which didn't had any state, or it was stateless, then it doesn't know about its past actions, right? It doesn't know anything. It just says, give me something, give me an input, and I'll process it and I'll just do that immediately. So if it was an reflex agent without any state and you pressed the down button, the lift will skip this guy because it doesn't remember its past actions, and it will start going down. And this is something that we do not want, right? We want it to store information in it. So a reflex agent with a state, what it does is, it stores the previous information as well. It has a state, right? So what it will do is, it will remember that I have to go upwards first. Even though you have pressed downwards, in my memory I have stored that first I have to go up. So it will first go up, pick this person, and then it will go down, and then it will actually like perform the action that you wanted it to do. So now this has a state, right? This has a state. It first went up and then it went down. So this is a reflex agent which is basically has a state. So agents are determined based on both the current perception and the agent's internal state. I'm talking about the reflex agent with a state, right? So this enables a more flexible and context-aware decision-making process, and it has an internal state which is just a memory or some sort of representation of the current and past states, which allows it to make decisions based on a broader context. So this was reflex agents with states. Now let's move on to goal-based agents. Now this is a bit different, and the way you can think about it is, goal-based agents just they do not only consider the current perception, but they also have internal goals and the ability to plan ahead to achieve those goals. Now, what does that mean? I mean, that basically means is like we can take an example of a chess playing program, right? Now this has a goal, right? It wants to win this chess game, so it has a goal, right? And it just doesn't act upon its current current state. It wants to get as much closer as possible to winning the game, which is its goal. Or you can also say its goal was to checkmate the opponent, right? So it wants to go closer and closer to that thing. So goal-based agents maintains an internal state that represent their current understanding of the world and their progress towards achieving those goals. And the way this goal-based agents select uh, their actions is based upon how this action will contribute to achieving the agent's main goal or agent's end goal. So these agents often use searching and planning algorithms that we will study later on. And they just use these searching and planning algorithms to determine the best sequence of actions instead of just the current action, like what should I do. So a chess playing program is the best example for these goal based agents. Now we have utility based agents. Okay, so what are utility based agents? Okay, so I'll start with an example, and that example would be of an autonomous car that evaluates different routes based not only on reaching the destination, but it also considers factors like traffic condition, fuel efficiency, and safety. So you see how it is different from goal based agent. If I program a car in a way that it is only a goal based agent, then it will not consider other factors like traffic conditions, fuel efficiency, safety, and all that stuff. It will be like, I don't care about anything else. All that I care about is just achieving my goal. That's it. I do not care how safe it is, how efficient it is, that the set of actions that I'm taking. All I want to do is complete my goal. So that would be a goal based agent. But a utility based agent, it also considers factors for efficiency and safety and blah blah other things. So a formal definition can be utility based agents go beyond a simple goal achievement, and they also take in account the desirability of different outcomes, right? Like how desired is this outcome, how desired is this outcome. So they basically assign utility values to states and outcomes, and they just try to maximize that overall utility value, which basically means is if you have a goal G, you are in S, start S, you just do not want to just complete the goal, right? You want to uh, you know do it in such a way that you did it with maximum utility values, right? So you, as I said, maximum safety, efficiency, and blah blah other things, right? So it wants to do things in the best way possible, right? It just do not want to do things like complete things. It wants to complete it with best things, like best way possible, right? So instead of focusing on achieving goals, utility based agents make decisions by considering the expected utility of different actions in various states. That's all. Now let's talk about learning agents, and then I'll finish this lecture 1.1, and then I'll make another lecture 1.2 that where I will go much deeper into environments. Okay, so the last agent we have is a learning agent. Now, what is an example of a learning agent? Now, this might be a little hard to understand, but let's say you are building a program for email spam filtering, right? And that email spam filtering program now needs to classify emails as spam or not spam based upon user feedback, right? Now it needs to classify things, or uh, I think another example can be, let's say, um, an image recognition program that can classify dogs as dogs, cats as cats, and it can classify different animals. So these agents are called learning agents, and learning agents have the ability to improve their performance over time through experience. They adapt and adjust their behavior based upon the feedback from the environment or from the user. And I'll give you a really good example of this in a bit as well to help you understand this even more. But the mechanism of learning basically goes like, they use various learning mechanisms like supervised learning, reinforcement learning. By the way, reinforcement learning is one mechanism that we will actually study at the end of this um, lecture series, right? Or it can also learn things through unsupervised learning. So the basic, very basic thing is, you want to acquire knowledge, and then you need to improve your decision making process. That's it. And I'll give you an example for this. Now let's say you are let's say you are in a world where you do not know anything about it. Let's say you are in this maze, right? Now this maze has fire here. This is fire. This is fire. This is fire, right? And you want to reach here. This is the place where you want to reach, and this is the starting point. And this is also fire, let's say. Now it doesn't know anything. It doesn't know that fire is here. It doesn't know fire is here. It doesn't know fire is here. It doesn't know fire is here, right? And it doesn't know where the goal is. It doesn't know that. You can think about it. It is just here. That's it. That's what it knows, that I am currently here. And what it will do is, it doesn't even know what fire is. So what it will do is, it will go here, and then it will be like, oh shit, this was fire. I just burned, and I just got killed. So now it will repeat. Now it will acquire this knowledge that do not go into fire, right? This would be the first point. And second point would be, uh, the first left is on fire. So now it knows that I should not go to the left, to the first left. So instead it will then maybe try going to the right, and then straight, and then it will like, okay, it will now acquire more knowledge, which is going straight or right first is good, right? It will say, I'm not killed, I'm not dead. So now this is new knowledge. And then it will be like, let's say if it went to the right and then it went straight, then it will be like, oh wait, do not take this path, do not take first right and then straight, because there is fire there, right? So like this it will try every single step, it will do everything possible, and then it will learn about these different things, right? And then finally it will be like, okay, I have reached this goal state. And now what happens is, now it has acquired this whole complete set of knowledge about its world, right? But it learned these things, right? And when we started, it didn't knew anything about this world. It didn't knew what fire is it bad, is it good, how do I reach to this goal state, and like what is the best way to reach there. But it learned it. So that is a learning agent right there, if it is able to learn about things. And I think humans are learning agent as well, if you really think about this, right? So sometimes you do not know, let's say a friend of yours came, and his name is, let's say, Magdalena, right? She came to you and she said, okay bro, I have these jellies, try them. Now now you have never ever seen these jellies in your whole life. You like are completely unaware, and you do not know how does it taste. Does it taste sweet? Does it taste weird? Does it taste sour? You don't know anything. But what happens is, once you will try this, once you will eat this, then you will know, okay, maybe this was sweet. Now you will, now whenever you will, whenever in your life you will see this jelly, you will know, oh yes, this jelly was sweet. But at first you didn't knew about this, right? You learned it by actually doing it. So this is how a learning agent do things. It takes some steps, it takes some actions, and then it sees, okay, what was the outcome of my action, and then it stores it in its knowledge base. So this is how learning agents work. So basically these were the four types of agents. Reflex agent, and it had a subtype, reflex agent with state. So I hope that I was able to convey these different types of agents in very simple way as possible. Please let me know if I was able to explain this well, and I hope I was able to do that. So thank you. Bye bye. Take care. See you next time.